Okay, cool. We got some people, admit all. All right, can you all hear me? Should all be muted, so if you just throw something up in the chat and lets me know that you can hear me. Perfect. All right, let's share my screen. How do I turn off the waiting room? Not in the meeting settings. I don't see how I do that, but that's right, everybody's here. All right, so for those of you guys who don't know me, one second, let me close the door. We don't get distracted. All right, so for those of you who don't know me, my name is Sam Taggart. I've been doing LabVIEW for about 12 years. I've got a whole bunch of titles after my name, but basically I've been doing LabVIEW for 12 years, worked in a whole wide variety of projects, and now I do consulting. I used to work for a company that built nuclear power plants. And so at that job, I worked in the R&D department, so I got exposed to all kinds of LabVIEW stuff. All right, so before we get started, I do want to make a couple announcements. I don't know how many of you guys are familiar with GDevCon and what they've been doing over in Europe, but basically a handful of guys a few years ago, I guess, got, I don't want to say upset, but we're not happy with what NI was doing as far as conferences, and they decided they could throw their own. And they did, and it was very successful. And so I've been talking to those guys, and I've been going to those conferences, and we're going to do something similar here in North America. So July 15th through 17th in Boulder, Colorado. We're not selling tickets yet. We still got a few things we got to work out, but we do have a venue and a date. The website's up there, gdevconna.org. We are looking for sponsors and presenters. The call for presenters is open. So if you go to the website, there is a thing there. Hello, everybody on the chat group. And then there's also an email list. So if you scroll down to the bottom of that, there's an email list you can sign up for, and you'll get updates about that. We may have tickets available before the end of the year. I don't know yet. There's a few things that have to be in place before we can start selling tickets. And then classes. So I am going to be offering a few classes. The first up is a DQMH class. It's a 3-day in-person class, January 29th, 30th, and 31st. That would be, what is that, Wednesday, Thursday, Friday. And it's content put together by Fabiola. So if any of you guys know Fabiola, she's pretty awesome, and she's very good at what she does. And she's put together a bunch of content on DQMH, and I'm going to teach that. And it talks about how to set up a project, how to decide which modules should be responsible for which, and how they talk to each other, and setting all that up. And then it covers some advanced use cases as well, and covers a little bit of unit testing and test-driven development. And then the day before that, on the 28th, I am doing a 1-day unit testing class. And if you go to the website there, automatedenver.com/upcoming classes, you can see that my unit testing class is going to cover everything from very beginning unit tests to very advanced stuff like using test doubles and mock objects, and how to test active framework and DQMH code. So the DQMH class, I was not planning on offering it remotely, Tom, but if you are interested in sitting for 3 days, I can definitely do that. So if that's something you're interested in, send me an email and I will look at that. I was going to do the 1-day unit test class as like a trial to see how how doing a full class over Zoom works. I feel like an hour is plenty of time. You can but you can still keep people's attention. I don't know if you can keep somebody's attention for a full day. So I don't know. But yeah, send me an email if you're interested in that. There's something else I was going to mention. Oh, I'm also going to be offering the, okay, Tom, we will talk about that. I'm also going to be offering the DQMH class in, what day is it? I'm going to offer it in April because there's someone else, I think they're on here. I think Ruben Tisnato also wanted to do the DQMH class but couldn't do it in January. So, well, all right, Tom. I will definitely talk to you about that. You may be the guinea pig, but hope we can make that work. Cool. All right, so the last thing I want to talk about, and I mentioned this, I think at the end of my last presentation, and a couple people signed up. I'm interested in starting this LabVIEW mastermind group, which would be kind of content along the lines of what we're talking about here, but maybe a little more in depth. So I view this, and I view like going to CLA summits and all that as more educational, right? So whoever's talking gets up there and presents and maybe ask a few questions, but that's it. And then you disappear. And oftentimes, you know, you gain the information, but you don't actually apply it. And so the LabVIEW Mastermind is kind of a group of people who are really committed to becoming better LabVIEW programmers and helping each other out. And so we're going to meet twice a month. So the first time of the month will be a little lecture on some small topic, and then we'll talk about it. And then the second half of the month is everybody disappears, goes, applies it, and comes back, and we talk about all the challenges we face, and we kind of exchange ideas. And then part of that too is we're going to do these things called bottlenecks, where basically you get up there and you say, hey, look, you get a couple minutes to explain, this is a problem I'm having. Everybody gets to ask some questions. And then like as a group, we kind of like brainstorm on a solution. So it's a very powerful thing. I'm part of this business development group, and we do that, and it's quite powerful. You get some really interesting ideas when you get everybody in the group collaborating like that. So if you're interested in that, email me and I'll send you a link. We are having our first kickoff meeting this afternoon. I want to say 3 o'clock it is. So anybody can come to that. And then that first meeting's free. And then after that, I'll tell you all the details. There is a small payment involved with that, but I think it's a really awesome idea. So, and I've got some really awesome, great LabVIEW people signed up for that as well. So it's kind of like a meeting of the minds. All right. So I originally did this presentation at GDevCon, the first GDevCon in England, and Fab has this thing about our giants are female. She wrote a blog post about it. And it basically says that, you know, there's the Isaac Newton, I think it was, quote that says we stand on the shoulders of giants, right? And that, you know, we're not starting from scratch every time we invent something or do something cool. And Fab's point was that women often fill that role of being the giants, but they don't get recognized. So you may have heard me talk about the Liskov substitution principle. You may have heard somebody else mention it, probably Dimitri. And I don't know, for some reason, I'd never read much about it or anything. I just heard Dimitri talk about it, and the name, it sounded like some old Russian guy. But it's actually a woman from Stanford. And she was one of the first women in the US to get a PhD in computer science from Stanford. And there should be a couple other things there. Yeah, Liskov substitution principle. She did some AI stuff at chess. And she also is currently, or was when I wrote this, head of the programming methodology group at MIT. And they're working on something called the Byzantine general problem. And if you've read anything about Bitcoin or blockchain, that's basically, it's a problem of you've got a bunch of things out there, and they're trying to get them to agree on what the truth is. Because anybody can add chains to the blockchain, so how do you know which one's the right one to choose? And that's what that problem is. All right, so now we're into the refactoring part. Before we get started, this kind of ties into the last presentation, because I talked about test-driven development, and we had this cycle, how you start with, and they don't trust each other. I'm not sure where that comment came from, Mike R, but now I got this. Oh, from the Byzantine general problem. Yes, absolutely. Okay. So how this ties into the last presentation, we were talking about test-driven development. We were talking about the cycle, right? How you decide you want to add a new feature, you create the tests without writing any code, and then you write the code that makes the test pass, right? And then before you move on to the next thing, you do take some time and do some refactoring and leave your code in a better state. And so this presentation is all on that act of refactoring and how we can use our tests as a kind of a safety net. So we use our tests, we make some changes, and then if we break something, we know. And this is going to talk about kind of the art of making those changes. So when I say refactoring, right, just get a picture in your mind. When I say refactoring, what do you really think of? And how many people thought of something like this? And this is real code. This is like the first project I ever inherited. And as you can see, it really is a bit of a mess. Nobody's ever seen any code like this, right? Well, that's not really this presentation, right? This presentation is not how to fix this. If you want that, you should go talk to Fabiola. She enjoys doing that type of work, and she has a whole presentation. I think it's called "Finding the Spaghettis in the or the Meatballs in the Spaghetti." Right? This presentation is more about preventing you from ever getting to this point. You can definitely use some of the refactoring stuff we're going to talk about on code like this, but that's not really my focus today. Really, to me, refactoring, part of it is about reducing friction, right? Code is read more than it's written. And so, as an example, I just went the other day, this guy called me over, and he had this program that had started out, it was doing leak checking or something, and it had a serial instrument that it talked to. And they'd written this program that talked to it and did some tests. And then they weren't happy with one test, so it ended up doing 3 or 4 tests, and they added some tests to talk to some other serial instrument, right? But they ran it all from this one GUI that did 5 different things. And over the years, all those things went away, except this one thing still stayed there. And then the one thing that they were doing, that machine went obsolete. They bought a new one that has a different serial interface. And now they're trying to figure out how to adapt this old program to the new one. But it's really hard to figure out where the heck it's actually writing to this particular serial interface, because there's like 5 different serial interfaces, and it's a huge state machine with like 20 states, right? All that code that's not being used, right, was generating errors and causing problems. They'd run it and they get an error from some serial port that they weren't even used because they didn't have anything hooked up. But in the initialize, it was trying to initialize this instrument that wasn't there, right? And you can see it would be a big problem to try to figure out. And they spent way more time digging through the code trying to figure out what to change than they did actually changing anything and actually adding any value, right? So reducing friction, right? We want to get rid of things that don't help us, things that make it hard for our code to understand, unused code, features that aren't ever used, right? So it's this like minimalist idea of trying to reduce your code to the bare minimum that gets the job done and is understandable. And I feel like when we write code, we kind of face this dilemma, and there's like really 2 camps when it comes to software development. Right now, I know I got the angel and devil. I don't know if they're in the right order there, but the one side says, and I'm sure you've probably heard this acronym, everything should be s'mores. Everything should be scalable, modular, optimized, reusable, extensible. And then at the very end, they put simple, because if you do all those other things, it's probably not very simple, right? So it's to remind you to keep it simple. And there's nothing wrong with that in and of itself, but their whole thing is you should design this stuff in up front, right? So your design should be, you do a big design up front, you account for all these things, and then you're gonna have a great design and everything will work. The problem is, the other side, you ain't gonna need it, right? You put in all this stuff to allow people to add extra channels and all this stuff, and they never use it. And all that unused code, A, creates friction, like we just talked about, and then B, so it creates friction, and then also it introduces potential bugs, and it's more code you have to maintain and debug. That is a very good piece of advice, Tom. So Tom says, I think of refactoring as redoing the things I knew I should have done better to start with. It'll be okay to cut this corner, and then future me, why did I do that? And so as we'll see, so TDD was the cyclical thing. Refactoring is also kind of this cyclical thing. And as we see, they work together, because with TDD, you can cut the corner to make the test pass. And then once you make the test pass and you have a test that passes, then you can use that as kind of a safety net, and then you can make all the changes you want and reorder and refactor and rename stuff and do all the stuff that you knew you should have done first. And then you'll know if it works or not at the end because you have the test to pass. Now, both of these things can also be taken to an extreme. So on the s'more side, we have what I refer to as architecture astronauts, and maybe you've met some of these people. Their code is nice and clean and neat, and all the lines are straight, but they've got like 20 or 30 layers of dynamic dispatch or VIs for you to click through to find something that actually does anything useful, right? Everything's all abstract and abstracted away. And if you need that level of abstraction, that's probably okay, but I would argue most programs probably don't. But then on the Yagni side, you can go way too far too, and you can become what I call a get or done programmer, which is kind of what Tom was referring to, right? You cut all these corners just to get it done and make it work, and then you don't bother refactoring, and you just let it that way. And well, it works, why would I fix it, right? And again, it comes back to that whole idea of friction, that every time you open that code, even if you don't have to change that part, your brain still like looks at it like, what the heck's going on there? And you spend all this time figuring it out, and then you figure out, okay, well, that doesn't affect what I'm gonna change, so I don't need to worry about it. But, you know, and also too, like the more complicated it is, the more it becomes like a house of cards where you're afraid to touch something because you're like, oh, if I change this, I don't know if it's gonna break something else. And there's a book that I should mention called Clean Code by Bob Martin. I haven't read it, but Chris Stryker gave an awesome presentation on it at an iWeek. And if you can get a copy of that, I want to say the presentation is on the LabVIEW wiki. I don't think that the slides are. I don't think the actual presentation got videotaped, which is a real shame because it's probably one of the better presentations I've seen. So, you know, we feel like we're got to choose. We're getting pulled these two different directions. It's kind of a false choice, right? I think there's a way to kind of keep the middle ground and kind of get the best out of both of these philosophies. And that is the author of the, yes. Ruben, if your question was about the author of the book, it was Bob Martin, Robert Martin. He's affectionately referred to as Uncle Bob. Yeah, there is a whole series. And he's probably written more books than that, I think, too. I think he just came out with a new one recently, actually. All right, let's see. Okay, so you see the framework, right? And the framework gives us some of that s'more stuff, some of that added flexibility. But the benefit of using a framework instead of developing it ourselves is it's already been tested, it's standard, right? So everybody else who comes along is going to understand it and not going to be confused by it because they understand the framework, hopefully. Right, so we get all that, and basically from the Yagni side, we get it for free. Because yeah, we don't need it, but we're not paying for it, we're not writing it, we're not maintaining it, it's just there. And then the next thing is do a little bit of design up front, right? Figure out your main modules. We're gonna do this at the DQMH class if anybody ends up taking that. And you lay out your modules, you draw your bubble diagram, you say, I have a module over here that's my GUI, I have another one that's my controller, and you draw lines between saying, hey, this one talks to that one, and you kind of get that part of it done. But don't really do the details, just kind of get a general idea. And then write some tests, right? So decide on some of the things that you can test really early on, and then start coding. And one thing that I will mention that's a really useful tool thing that I got from Frab, and I think she got it from the Pragmatic Programmer book, which is also another good book that I haven't read, but it's sitting on my shelf. But I've heard Frab talk about this, and I've heard the guy who wrote that book talk. He calls them tracer rounds. So you start at like the lowest level and you try to find some feature that goes all the way through your program, right? So like, for example, if you've got a program, it's got a database, and it's got some hardware, find something that like some feature that reads a value from the hardware and processes it and then puts it in the database, right? And then that kind of gives you an idea of like if you're on target or not, and if everything in your whole build chain and everything works. So that's a really useful tool that I just thought I would mention. Tracer rounds refers to like in the military. I don't know if anybody's into that, but or knows much about that. But if you have a machine gun and you just start firing, they put these tracer rounds in it so that you can then see where the bullets go, and if you're off target, you can just adjust. And so the tracer rounds in the software just tell us if we're on target, if it's going to work or not, and then we can adjust as we go. But then once you start coding, continuously refactors, right? So do your test during development, and every cycle, make sure you do that refactoring, right? So you get the test to pass, you know it works, and you've got a test that proves that it works. Then you've got the freedom to be able to make changes because you'll know if you broke anything because the test will tell you. And then the other thing that I think is important is, some people criticize test-driven development because, oh, well, you're so narrow, you're just focused on this one module or one VI, right? And you're just trying to make it past the test. But there's more to design than just designing one VI, right? You got to design the whole system and how it interacts and all that. And your larger architecture stuff sometimes doesn't work out very well if you're just got this narrow focus. And so that's where I say, make use of design patterns, right? Design patterns will give us flexibility. And as you're refactoring, think about how you can take what you have and turn it into one of the design patterns. And I want to say there's actually a book on that as well, but I haven't actually read that. But I think it's called like Refactoring the Design Patterns. Yeah, I don't know. I have a really big reading list, and that's definitely on there somewhere as well. So what do we get out of this? Because this sounds like a little bit more work. Well, one of the things I think we get by using refactoring very liberally throughout our process is I feel like we get faster turnaround time on our projects, because the old waterfall way is design everything up front, right? And it takes a lot of time and energy and effort. And this way we're spending less time designing, right? We kind of have some idea of where we're going. And then as we start moving, we can refine it. And there's a famous saying a buddy of mine really likes, and it's called like, planning doesn't create movement, movement creates the plan, right? So you have some idea of where you're going and you just start moving. And as you're like doing stuff, you're getting feedback and you're incorporating that. And then that's kind of directing where you go and helping you to like finalize all the little details, right? So you start with the details of your plan of how many modules you have and how they talk. And then as you go along and start writing code, then you start refining, okay, well, this one talks to that one, but these are the exact messages it sends, right? And this is the data that it sends, and this is a structure. Rather than trying to figure all that stuff out ahead of time, right? I feel like when you try to figure it out ahead of time, it always changes anyway. So, and then the other thing is we just have less code to write because, we're not trying to do the s'mores thing and build everything in up front and all this extra stuff that we're not going to use. And because we write less code, there's less code to test and debug and maintain, which is a really nice thing. And then I feel like we get more robust code because it's easier to understand, because it's simpler. We're not doing all that extra stuff, and it becomes easier to debug. And I think we can do all this and still maintain flexibility, because by mastering refactoring and knowing that we can refactor stuff easily, then we can refactor into a design pattern in order to add flexibility in a particular direction whenever we need to. If anybody has any questions, feel free to throw them in the chat. I think I say that at the beginning of every one, but I just want to make sure that everybody gets that message. And if I'm going too fast, tell me to slow down. But basically, here's the roadmap for the rest of this presentation. We're going to talk about some refactoring basics. Right? Then we're going to talk about some simple tools, some things you already use. And then we'll do a really simple example of some OOP refactoring, and I'll show you a tool that I've been working on. And then we'll talk about some caveats, some things, some gotchas that you got to watch out for when you're doing refactoring, because there are a few things that can trip you up. Here's the reading list for this presentation. I told you I have a big reading list. I read several books a year. I've actually read all of these. There's a whole bunch more books that I haven't read, but this presentation is mostly based on the refactoring book and mostly the design patterns book. The original, the blue one there is that Gang of Four. If you hear somebody for the Gang of Four, you'll see it abbreviated GOF. That's that blue book there. And that's kind of the old standard. The one on the right is a newer version of that. That's Stefan. And I think I saw him on here. Lamans pointed me to. And it was on sale recently. I might still be on sale. So you can get that for 20 bucks. It's a very worth the 20 bucks. And then the UML distilled is just useful for the design pattern books, because that happens. Yes, Stefan put it up there. It's from refactoring.guru. My only complaint is it's only available in an ebook format. I would love to get a print copy, because I like taking them and highlighting them and marking things up. And then the UML book's just kind of there because a lot of the design pattern stuff uses UML diagrams to explain things. It's been a while since I read the refactoring book. I don't remember if it has a lot of UML or not. But basically, in all those books, the refactoring, the design patterns books, they have examples, but they're not in LabVIEW, obviously. But as far as examples go, the design patterns book on the right has examples in 7 different languages. So It's got Python, C, C++, or well, actually probably not C, but C++, PHP. There's a whole bunch of them. And so I just know it has the Python ones because I happen to know a little bit of Python, so I was able to follow those. Anyway, so if you want to do some reading, any of these books are great. I highly recommend them. There's a new version of the refactoring book that came out. I don't have it. But. All right, so, you know, I used to do a little bit of martial arts way back in the day, and I've always thought that the secret to becoming a master is to master the basics. Right? People think that being a master of martial arts is about doing spinning back kicks and all this stuff, and it's really about doing the basics very, very well. And there's another saying too somewhere, something like, amateurs practice till they can get it right, masters practice till they can't get it wrong. So it's just about hammering home the basics, and a lot of the things that we're going to talk about in the next little bit of this presentation are really basic concepts, but really understanding them and putting them to use is really going to help you out a lot. And so the first thing is, all code is written for two audiences. So does anybody want to guess? Throw it up in the chat. What are the two audiences? Yes, Ruben, this will be recorded. It should be recording now. It's not. Did it say it's for being recorded? It is recording, so yes. Your future self, yes, that is definitely one of them. But the first one is actually the compiler, right? And the compiler just knows you send it low-level commands that say, like, add these two numbers. And all it really knows is, oh, I'm supposed to add these two things, or the things you sent me, can I add them? Do I know how to do that? Okay, great. It doesn't have any clue of what your intent is. It doesn't have any clue that you're adding these numbers and multiplying together to try to convert Celsius to Fahrenheit, for example, right? It doesn't know. And it won't find mistakes in that code because, you know, as long as the math functions are valid, it just spits out a number, right? And so it's really easy to write code that the compiler understands, but that either makes no sense or that human beings just can't quite understand. And so the second audience, of course, as somebody mentioned, is human beings, right? So as Fabiola always says, be kind to your future self, right? Because the next person who's going to read that code is probably you. Right. Questions. So my thought process is always you should optimize the code for the human beings reading it. You know, if you have performance problems or whatever, then you can go back and optimize it for the compiler. But in general, you know, code is written way more than it's, or read way more than it's written, right? So that goes back to the very beginning of the presentation. All right, so you know, we throw around this term refactoring and stuff, but we haven't really defined it, right? So Martin Fowler, who wrote the refactoring book, says it's the process of changing a software system in such a way that does not alter the external behavior of the code, right? So we're not adding features from the outside world. They don't even necessarily notice that anything's changed, but it improves its internal structure, right? So we're taking a house of cards, we're keeping the outside looking exactly the same, and we're building a nice foundation under it, and we're putting brick walls and stuff so it doesn't fall down. And it's not about adding functionality. But it is related in some ways, in that when we want to add functionality, right, it usually means extending our program in a certain direction. We have design patterns that do that. So what we do is we take our code that's maybe a spaghetti mess, hopefully not, and then we refactor it so it looks like the design pattern. So it's still doing from the outside world, it's still doing the same thing, but now it looks like the design pattern, then it makes it really easy to extend it in one direction. I want to say that's like the next slide. Oh, one after that. But you know, we're taking something that looks like this, right? Spaghetti, true spaghetti mess, and boom, we're turning it into a nice printed circuit board where all the lines are straight. It's nice and easy, right? I mean, if you had to replace a resistor or something on the one on the left, it would be a pain, right? First, you got to find it, and you got to dig through all those wires and make sure you don't like loosen any wires while you're doing it. And it's a huge pain. The one on the right, super easy. It looks like those chips even have sockets on them, so you just pop it out of the socket, pop it back in. Very easy. So that's what we're going for. Now you might be saying, okay, well that's great, but if I'm going from this spaghetti mess into something nice and neat, I might break something. And that is totally true. But we've got some tools to help us with that. If you don't recognize the icons, the one on the left is the icon for Git. right? So we use source code control, right? So before we change anything, we make sure we have it in source code control. And then the icon on the right is for JKI VI tester. You don't have to use that one. You can use any unit testing tool you want. And basically before we start, we run the test to make sure that everything works. And that's actually a really good habit to get into. And you might say, well, I haven't changed anything or whatever, but maybe you checked it out on a different computer and you're missing some dependencies or something. So it's always a good habit that when you start working, you check everything out of source code control, you immediately run the unit test just to make sure that nothing broke. Right? Somebody else might have checked something in that you didn't notice and now something's broke or whatever. So always get in the habit of running the unit test first. Then we go make our changes and then we check back in at the end. Right? So it's kind of cyclical, right? So we start with working code in source code control. We make a small change. We run our tests. If we like the results, we commit. If we don't, we roll it back and we keep doing it over and over again. Right? And the best way to do it is to make one small change at a time. Right? So, you know, last time I gave this presentation, people asked, well, how small of a change? And I say very small, but, you know, it depends, right? The question is really how much work do you want to lose, right? So if you make, you know, multiple changes before you run your test and commit, well, then if one of them breaks, you may end up losing that whole 15 minutes of work or half an hour of work, right? If you just make one change and change one VI and then test it, well, if it doesn't work, you can immediately roll back that one VI. So it's kind of a personal preference thing. As you get better at refactoring and you know, okay, I can do all these things and not break things, then, you know, you might be able to go a little bit longer between this cycle of committing and checking in. Does that make sense to people? Perfect. So yeah, I mean, it depends too. Like sometimes like I might, you know, for like production code, the code that's already out there and I'm just fixing a bug, I will be very painstaking. Every git commit will have exactly one VI that has one thing changed in it, right? But when I'm starting a project maybe, and I know I've got a lot of changes to make and I'm pretty confident that I can make those changes without breaking things, I might work for half an hour before I run my test again and commit. So it just kind of depends. All right, but when should we refactor? I kind of view refactoring kind of like a hygiene thing. It's kind of like dusting the house or taking out the garbage or vacuuming the floor or something like that, or doing the dishes, right? You just want to keep doing it continuously. I think part of the problem is if you don't do it continuously and people see code that's messy, it almost like it gives them permission to be messy too, right? So like your house can be spotless and everything's fine, and then all of a sudden like somebody leaves a dish in the sink. And if it doesn't get fixed right away, then the next thing you know, somebody else sees that and says, oh, well, it's okay for me to leave a dish in the sink. And next thing you know, your sink's full of dishes, right? And then, so those are times to refactor. Some of the other times, like untangling spaghetti code, and I thought I changed this. I guess I didn't save those changes. Untangling spaghetti code and trying to understand it, right? So if you get something that's just complete spaghetti code, you know, you can do some refactoring, move some stuff around to try to understand it, clean up some block diagrams. Preparing to add new features, right? So this quote by Kent Beck is really great. For each desired change, so you want to add a feature, make the change easy, right? So that means massage your existing code without adding any features, change it, refactor it into a design pattern that allows you to make that change. And then you make the change that's really easy. Like, for example, a lot of the design patterns revolve around inheritance or something like that. So you create it so that, hey, I have this interface or this class that I can inherit from, and then I just inherit from it and inject the new class and everything works. Okay, so I see a couple questions. So Mark asked, how often do you commit during a day's work? That just kind of depends. I probably commit fairly often. I probably commit several times an hour, maybe more, at least locally, right? So with Git, you can commit locally and then decide when you want to push. I generally don't push all the time, but sometimes I do. Definitely like when I'm done with a feature, I'll push that. In the middle of a feature, like I use Git flow. So no, I do not bother squashing commits. I think squashing commits is for nice looking history. And in my mind, The goal is not to have a nice looking history, but to have an accurate history. So squashing, right, it looks nice because you've just got one change for one feature, right? And you can revert the whole feature at once. But if you have a bunch of different commits, then you can see all the individual steps. And, you know, yeah. And if you want to revert the whole feature, you can just revert the whole branch and not revert all those changes, and then you're good too. So I don't see a lot of value in squashing commits. I mean, I think that comes from like the open source people who want their graph and get to look nice and neat. And I don't really care what the graph looks like as long as it's true. So Tom, unit test framework comes with LabVIEW and I like it. However, I don't see many presentations mention it. Is there a reason? Yes, so in general, I think the community is not a huge fan of it. And I think that it has been not very well supported by NI. So yeah, I think it's still around. I think the other reason too is you have to pay for it. So if you're an alliance partner and you get a deal, then that's great. But if you don't, I think it's like $5 grand or something per seat or something like that. And also, from what I understand, it's rather awkward to use. So there was a lot of hype and it was big to do when they came out, and then pretty quickly they just kind of abandoned it. The one reason to use it, the unit test framework, is because the NI is ISO certified. But there's another competitor now out there called InstaCoverage, which is also ISO certified. So if you need ISO certified, you can go with InstaCoverage and meet that requirement without using the NI unit test framework. Other questions? Good question, Tom. What software do I use for source code control? I use Git. I highly recommend you use something like Git that's distributed. It seems to be the way to go. Some people are still using Subversion. I've used Subversion in the past. It's not terrible, but I think Git has a lot of advantages. Lets you do very lightweight branching and merging, which is really nice to keep people from stepping on each other's toes. And you also have to do some software design in order to do that. And so I use Git as the underlying mechanism, and then I also use SourceTree to manage it from a GUI perspective. I also kind of like Tortoise SVN. I have them both installed. I like Tortoise SVN because I like being able to see in the Windows File Explorer what's changed. And also their mechanism for reverting changes is really good because it lets you highlight a whole bunch at once. And SourceTree, you can kind of do that, but so for that I like Tortoise, but I do like SourceTree, and it has like a get flow button built in, so you could just say, hey, create me a new feature, and it automatically names the branch and everything. And then when you're done, you click on finish feature and it automatically merges it into the correct branch and keeps track of all that for you. So I like that. My biggest problem with get flow is I forget to create a new branch. And then I have to like stash everything in Switch, and it's a pain. That could probably be a little bit better. My buddy Jorg likes something called Git Tower, and one of the features that he talks about that he really likes that I think would be really useful is if you're on development and you have on committed changes and you create a feature, it automatically stashes them and moves them over for you, which is pretty awesome. But it's paid, so SourceTree's free. All right, so what kind of tools do we already use that are doing refactoring for us? So a lot of refactoring is repetitive, and so you can easily create tools. You can write your own scripting tools. Tom McQuillan is the scripting tool ninja. Oh, Christian, Git Bash. Ah, cool. So yeah, Git comes with Git Bash, and so sometimes I'll do command line stuff too. If I know exactly what I want to do, sometimes it's easier to do it in the bash command than doing it through SourceTree. I think it's worth kind of knowing all those things because ultimately SourceTree is just a wrapper for the bash commands. So if you know what the bash commands are, and if you don't remember the exact syntax, at least if you know what they are, you have some idea of what the commands do in SourceTree. And then also in SourceTree, you can see all the commands as they're being typed into the shell. That's one thing I don't like about Tortoise. It's like the model is based off of SVN and it doesn't exactly track the Git model. So there's a little disconnect there, but All right, so some tools built into LabVIEW and some things that are automated for refactoring. I recommend for learning Git, there is a book by O'Reilly with a bat on the front, and you want the full-size book, not the little pocket book. And if you read that, that will definitely get you started with Git and teach you all the commands. It's super deep dive. They also have another book called like Working in Teams with Git or something, and it's on my list. It's on my thing, but I haven't. It is O'Reilly. O'Reilly, they produce a ton of like computer books on various programming languages. And it's the one with the bat. And it's actually, it corrected that for me, so it's O'Reilly with a I. There you go. That's probably it. That sounds about right. Yes, I'm looking at it right now. Yes, it is the second edition. It's sitting on my desk. And they also have like a pocket reference too. So, you know, if you buy the big book and read the big book and then just keep the pocket reference handy, it's useful. Yeah, Christian put a link there for you. So block diagram cleanup, right? That does not change the functionality of your code. Anything that calls your VI doesn't care that you run block diagram cleanup, right? And the compiler doesn't care. It doesn't change anything that goes on behind the scenes, but it makes it easier for you to understand, right? So that's a very good example of refactoring, right? We're taking code that was written for the compiler to understand, and we're making it so that the human can understand it. Renaming controls and indicators is another one, right? LabVIEW doesn't care that your VI is named Untitled, right? But that doesn't convey any meaning to you as a human being reading that code. So renaming controls, indicators, VIs, methods, classes, libraries, all that is refactoring. Creating a sub-VI, right? It changes the code inside your VI, but from the outside world, it doesn't care if it calls a sub-VI, it doesn't care if that sub-VI calls another sub-VI. Yes, there's a whole bunch of them, and maybe Tom McQuillan will chime in with some of his favorites. He did a presentation recently at GDevCon that listed a whole bunch. And you can create your own. And if you want to, talk to Tom. Tom will tell you. Perfect. Natify your VI is a very good one. Yeah, it's a quick drop plugin, and it does stuff like turn off automatic error handling and resize stuff and move it around and basically clean it up. It's like block diagram cleanup, but much a lighter version, but does some stuff that block diagram cleanup misses. So create sub-VI, insert sub-VI contents is also a refactoring. That generally doesn't make your code easier to see, but sometimes it does. You know, if you've got like multiple layers of sub-VIs and some of them just delegate to another sub-VI, well then, you know, inline that and get rid of that sub-VI call, and it'll make your code easier to understand because they don't have to click through so many things. There's something called create object from cluster. So when NI first came out with objects, they didn't have them, but everybody's using type def clusters everywhere. So they had a thing where you could right click on a type def control and convert contents of control to class. And it takes your type def, puts an object there, and takes your control and moves it inside the object. And it does require some more work, because then everywhere that you're using the unbundling the cluster, you have to decide, do I want to move that in the class or not? Because it's going to be broken, right? And so then you move those VIs or create methods on your class and everything. And as long as that doesn't cross any boundaries, that's refactoring, because you know the outside world doesn't care if it's a type def or a class you're passing around. There's AF and DQMH rescripting tools that will rescript messages for you. Those could be considered refactoring, right? It just kind of depends on what you consider like the boundaries, right? As long as whatever you're doing is inside some boundaries that the outside world doesn't care, then it's considered refactoring. If you're crossing those boundaries, then I'd say you're adding features. I want to say Tom also has a very cool YouTube channel that probably goes over some of this stuff. I haven't watched too many of his YouTube videos, but I hear it's very good. And I imagine he probably goes over some of this refactoring stuff there as well. All right, so we're going to do a demo in a minute, but let's just say as an example, and this is more of a real world type example, you've got a program, it uses an Agilent DMM, it takes a few measurements and averages them. So here we're reading 10 points, you know, add them up, divide by number of points, and we're graphing it as well, right? Simple program. The customer program works fine. The customer says, all right, well, we want to have another test station that can do the same thing, but we don't have another one of these Agilent DMMs, but we have this NI 4070, it's a PXI DMM. I'm going to have to go watch that, Tom. I've watched a few of them. I need to watch more. I'm sure I could pick up some interesting tidbits. So, you know, they have this 4070 and they want to run the same exact code, right? And they're smart enough, they don't want to just copy it. They want to write one set of code that runs on both, right? Which is the right way to do it. And so we want a piece of software that we can put on both. They're both running the exact same software. We just change which DMM we're using. And this may be part of like a bigger program or something as well, right? But here's just a simple VI. So if we're going to start with the end in mind, right, and we know where we want to go, what type of design pattern, because somebody throw out a name of some design pattern or some template or something that we might use, right? I'm thinking specifically of like a 3-letter acronym that gets thrown around a lot. State machine. SSM, QMH. Okay. Yes, you guys are definitely on the 3-letter acronyms, but John nailed the one I'm thinking of is a HAL, right? Hardware abstraction layer. Tom AF has only 2 letters, but you could do it in any of these, right? But we're gonna use a HAL, right? And so we're gonna follow Kent Beck's advice. We're first gonna change our code to use the hardware abstraction layer. Great, and that's going to allow us to expand by adding different types of devices, right, as long as they follow the same interface. So that's going to make adding a new DMM really easily, right? So if we had this DMM parent class and the Agilent DMM to begin with, to add it, all we'd have to do is create a new child class for our 4070 DMM and then somehow pass that in there, right? So that's the making the change easy. All right, see you later, Stefan. You'll get a link to the video, so you'll get to see everything you missed. All right, so this is what it's going to look like at the end. And then, so back to our example, right? The customer then says, okay, well, our current code works, right? With the DMM that we have, it's in source code control. So we got that part out of the way. And let's say we have both DMMs sitting on our desk and we have a power supply and a function generator. What does anybody think should be our next step? What should we do before we start doing anything? Write a test, right? Yeah, so we're going to come up with some kind of test. Now, it'd be great to do unit tests, but since it's talking to hardware, this might be kind of hard, right? And it's not really set up to do that at the moment. We can work towards that. But we have hardware right there, right? So we have everything sitting in front of us. So we can hook up a power supply or function generator to it. And we can come up with some kind of test that says, yes, this is doing what it's supposed to do, right? So we come up with a test, we verify it. Just because the customer says it works doesn't mean it works, right? And again, even if the code works itself, you might install on your computer and find you're missing the driver for the Agilent code and it's not going to run, right? So start with running code. Now, here are the next steps of what we have to do, right? We're going to create, I lost all my changes. Did that not save my changes at all? Oh, auto recovered, All right, hold on. I need to pull this up because this is going to have my latest changes. It is missing my changes. All right, I changed the order of these a little bit, but all right, so basically, right, we're going to build our class hierarchy around it. We're going to create our DMM class, right? So first step is, do I have to, is there another version of that? Really, I lost all those changes? That sucks. I had changed all those. Okay, I guess I don't. But anyway, right, so part of it is we're going to, so I did go through and note this, so just bear with me. First, we're going to take our existing code, right, we verify it works. Then we're going to create an object to wrap our Agilent DMM code, right? And we can test that without touching our original code, right? That's the first step. The next step is then to take that code, the object code, and put it into our current code, right? Replacing all the calls to the Agilent DMM with the object code. And we can run and test that and verify that works. Then we can add a factory to our object that just creates, in this case, I'll just create our Agilent one first. We test that, everything's good. So now we have in place, the code relies on the parent class. We've got a factory that creates DMMs. Now we've made the change easy. So all we have to do is add our 4070 DMM with the correct code, and we can test that separately. And then we add that to our program so that our factory now outputs either one, depending on which one's there, and then we're done. All right, so here's where we're going. We're going from this to this, and then we're going to replace the bottom part with, instead of relying strictly on the Agilent, right, we're going to select between the Agilent and the other DMM. And I have some code running. It'll take me a second to start it up. I thought I already had this running, but I guess not. Anybody have any questions so far? Can you guys all still see my VM? Okay, cool. All right, I don't know why that's taking so long. We'll skip on and I'll come back to that. All right, so there's some caveats when you are doing refactoring. So the first one is you want to be careful with changing control and indicator names. In your code, probably not a big deal, but when you inherit code, it could be a really big deal because a lot of old timers really like VI server and like, you know, manipulating stuff by name. And if you change the name, it could mess stuff up. If you're somebody like Tom who writes a lot of scripting code, or if you're using like Actor Framework or DQMH, some of that scripting code relies on the label of a controller, indicator, or constant to do things. So usually when I'm writing scripting code, I put a big note there that says, hey, don't change this because I'm using it for scripting stuff. Other things you got to be careful of, if you move or rename libraries or VIs on disk, right? Hopefully you all know you can cause yourself a lot of headaches and problems with that, with cross-linking and all kinds of other stuff and not finding things. If you do it in the project, so you open up the project, it's a part of your project, you go to the Files tab, you can move all you want and rename stuff there, and everything relinks. So make sure all callers are loaded. That's the other thing. So sometimes if you've got something that's in its own project but used in another project, right, that can be tricky trying to rename stuff, so just be careful with that. Reuse code, right? If you release something and it's used in multiple places, it's really hard to make sure you have all callers loaded in memory, right? Because if you've released it, you put it on the tools network or something, or you hand it off to your buddy, you don't know who all is using it. So it's hard to load everything into memory. And I really like the idea of using VIPM and packaging everything and then forcing people to edit the source code and re-release. So when I make VI packages, I have a special little post install VI or whatever that makes everything read only, so it won't let them overwrite it. And then if they want to change, they got to come back to me and ask, and I'll fix it. The other thing with release code is be careful not to change API methods, right? You're violating the open close principle. If you know anything about Solid, basically it means that once you put it out there, you shouldn't make changes that break existing code. So what you do if you want to do that, you leave the old method in place and it just underneath the hood calls the new method and you mark it as deprecated. So you'll see NI does that. Sometimes they put a big red X on stuff and they'll even say in the notes it's deprecated. And then eventually after a few releases, you can say, okay, yeah, I'm going to break your code, but you shouldn't have been using this anyway. And so it's gone. And also you want to use, you want to make stuff private as much as you can. So I wish LabVIEW had a way that when you create a new VI inside a class or library, it would automatically become private, kind of like when you add something connector pane, you can set it to automatically become required. I think that's an awesome thing. It's very easy to take private stuff and make it public. It's very hard to go the other way. Once you've released it, somebody could be using it, and now when you make it private, you break that code. So those are just some things to think about. Here's a cool resource, and that's it. Let's go back and see if the demo has loaded, because I want to show you guys this tool. When I went to full screen, could you guys still see my screen? Okay, good. I'm going to go back to full screen then. All right. When I'm in full screen, I can't see the chat window. So if you leave something there and I don't answer, that's okay. I will get back to it. If anybody has any other questions about any of the stuff we talked about today, or if you have questions about the classes or anything that we got going on, or GDevCon NA or any of that, go ahead and throw it in the chat box. I did not know AQ had that idea. I'm not surprised that it's on there. I look through that sometimes, but I don't always catch everything that goes on there. I should probably subscribe. All right, I don't know why this is taking so long to load. All right, so the tool I wanted to show you. So here we have an original. This is the thing that's calling directly to the Agilent driver. And then I've refactored it. So I've created a class. And these just call to the Agilent driver. But this VI is still depending on the Agilent class. So it's dependent on the Agilent driver. And we want to change that, right? So we need to add an interface class. So how do we do that? Well, I have some tools, class refactoring tools. And they're on GitHub. Or sorry, not GitHub, GitLab. And there's a couple here. So copy a class just copies it, just like copying it from the Project Explorer, except that I add some scripting tools to rename all the object constants and controls, which is really nice. Same thing with move class. But if I click on create interface, let me make sure this will work. This needs to be empty. Is it empty? I got to delete these first. 1 second. Okay, now it'll work. So I get this dialog box. I say, well, what class do I want to create an interface class for? Note, this is not the interface that is coming with LabVIEW 2020. I will probably have to rework this for that. This is just creating an actual parent class that does nothing, but just has all the methods. So I selected the class I wanted to create it from. I gave it the new location. I want to add it to the project. I click OK, and it will generate it all for me. So that saves you a little bit of time. In this case, not super useful because the class only has a couple methods, but if the class had like 10, 20 methods, it would be a lot quicker to do this. And it lets you make that red. And now I've got this IDMM class, and if I go to show class hierarchy, it's inserted it above my Agilent class, and it's got the same methods, and they're all blank. So now I can just create another child of this and fill in each of the methods with the calls to the 4070. And then I go back to my refactored and just put in like a select structure there or something that says, which DMM do you want to use? And it would pick between the two. And maybe a better choice would be to load it dynamically so then I don't have to have the Agilent DMM drivers on both machines or something. But hopefully you all get the idea. Anybody have any questions on the demo? The GitLab is gitlab.com. SAS, I want to say it's underscore reuse. No, underscore public. So you go to gitlab.com/SAS underscore public. The class refactoring tools will install all that. And there's some other stuff there too that you can look at. VMs, there are a lot of different thoughts on that. Right now, I tend to do it by LabVIEW version, but it's easy enough to clone one for a specific project. Generally, I have one that is my LabVIEW 2019 thing, and I generally do everything in there. And if I have a specific project that requires specific drivers or software for that particular project, then I create a new VM just for that. I mean, it also depends too on how strict you are as far as like what exact driver versions you use. You know, some people really, really care about that. For most of the stuff I do, it's non-regulated, so as long as it works, they don't really care if it's, you know, DAC version 19.0 or 19.1. Right? It's kind of the same as long as it works. So, does that answer your question, John? Yep. And then I'll just go back really quickly to the announcements. So if you have any questions about any of these things, GDevCon or any of the classes or the mastermind, you can just email me and I'll be happy to get you all the information you want, or you can check out the websites are there. So thank you guys. I apologize, we went a few minutes over. So if anybody has any, which VM provider? I use VMware. I happen to like it. I used to use VirtualBox. I now pay for VMware, but there are some people who still like VirtualBox. VirtualBox used to, I think, have issues with passing USB and hardware stuff through. VMware just seems to work. There's another one for Microsoft, Hyper-V or something. So if you do use VMware, you got to get at least version 15, which I think is what they're selling now, because I had version 14 and then I updated Windows and it broke. So that was not fun. But other than that, I haven't really had any problems with it. So they have like a Black Friday sale, so I think you can get it on sale right now because I just bought the upgrade. So I think any of them really work. I think it just depends on what you want to do. But I like VMware. I'm happy with it. I'm probably going to stay there. So and the other thing then is too, like licenses and how to handle all that. And VMware works really well with Windows licenses. You can clone it and it doesn't really complain. I don't know. I want to say VirtualBox always gave me problems when I cloned a VM. It gave me problems with the license. So, yeah, if you want to send me some questions about that in email time or whatever, we can talk some more. Yep. So, all right, well, go and enjoy the rest of your day. Hopefully you found this useful. Actually, a quick show of hands. Anybody interested in talking about mock objects next time and more unit testing stuff? Or is that too technical? Because I gave a presentation on that at NI Week, and I could do that, or not NI Week, the CLA Summit. I could do that here. I just don't necessarily want to go over everybody's head if people aren't really doing unit testing. All right, good. That's good. That solves my problem of trying to find a good topic for next time. We'll talk about mock objects, and we'll see where that goes. Well, there you go. Very good. All right. Yeah. Well, yeah, it's on GitLab, so you can go download it and try it out. Yeah, I think it solves some corner cases when you're doing unit testing that are really difficult to test without it. So I think that's the use. I don't expect it to be like super useful. Like I don't expect everybody to use it, but there's certainly some times when it's necessary. So very cool. All right. Well, thank you guys very much for coming, and hopefully I'll see some of you guys at GDevCon NA and or at some of my classes. So, oh, I should mention, I'm offering a deal. If you sign up for the DQMH class before the end of the year, I'll send you a coupon for half off the unit testing class. So if anybody's interested in that, check out the website or send me an email. All right, I'm going to go now, so I will talk to you guys later. Bye. All right, how do I exit this?